What if AI could save lives, unlock the secrets of our planet, and even explore distant worlds? From decoding Earth's atmosphere to forecasting wildfires, our experts at SSAI are using geospatial data, user-focused tools, and machine learning to reshape what's possible. This is artificial intelligence, and this is the future of science. Join Makhan Virdi, Brandon Smith, and Alexandre Belli as they take you behind the scenes of their groundbreaking projects, sharing how their innovative AI work is transforming science and making a real impact. The very first question I wanted to ask you three was, can you please tell the audience about yourself and describe some of the projects you have worked on at SSAI? Makhan, would you mind kicking us off?
Sure. Thank you, Jason. And hello, everyone. I'm Makhan Virdi. I am a lead research scientist at SSAI, and I currently co-lead our Deep Learning Academy along with Brandon. Deep Learning Academy, or DLA, is SSAI's flagship program for building AI and machine learning skills across our workforce. Along with Brandon, we have helped mentor several cohort of scientists and engineers as they learn and apply deep learning to real-world problems. For example, predicting air quality, detecting features in satellite imagery, and so on. It's been incredibly rewarding to watch people level up and bring AI into their day-to-day science and use a combination of their subject matter expertise with the new tools like AI. So before this role, I served as the DAC scientist at NASA's Atmospheric Science Data Center, which is housed at NASA's Langley Research Center in Hampton, Virginia. So that specific role gave me a deep appreciation for how we organize and deliver massive volumes of atmospheric data and how important it is to build tools that make data more actionable. I also worked on Maya mission and Tempo satellite mission, one of the newer NASA geostationary satellites. So I was involved in planning the air data quality products and metadata systems that will support the hourly volume of measurements across North America. So it's a big step forward in how we track and understand air quality in real time. It's one of its kind, first of its kind in the NASA world. Besides all these projects, I have also created Chat SSAI. It was a SSAI's internal R&D project. Think of it as our internal AI assistant that helps employees find resources and knowledge across our organization, like finding and figuring out who are the subject matter expertise in specific domain. Think of it as our in-house version of ChatGPT, if you like. Across all these roles, my focus mostly has been helping scientists do better science by combining these tools and data and a bit of AI magic.
Wow, that's awesome, Makhan. I really appreciate you highlighting your background and your experiences. Brandon, I'm going to turn it over to you. Would you mind telling the audience about yourself and describing some of the projects you have worked on at SSAI?
Yeah, absolutely. Thanks, Jason. So my name is Brandon Smith. My background is computer science, and that's focused on machine learning specifically. So I started out as a NASA intern about 8 or 9 years ago, and kind of subsequently joined SSAI to start working on the same stuff that I was working on during my internship. Namely, that was water quality estimation. So what that involved was applying machine learning to different satellite missions, Landsat, Sentinel, and trying to get estimates of water quality. So you can think like concentrations of chlorophyll, sediments in the water, and basically just monitoring those aspects that would impact human health along coastal regions. From there, Jackie Kendall recruited me to build the Deep Learning Academy, which Makhan already had mentioned. So that was, for those that aren't aware, a program designed to help scientists gain expertise in machine learning over the course of 7 or 8 months. And I'd say that went fairly well, given we're just now wrapping up our 4th cohort a couple weeks ago, and certainly Makhan and Alex themselves can attest to how well it is going. So from there, I've been mostly working on digital twins, and in particular building a machine learning based framework to enable the construction of digital twins. So digital twins are essentially answering 3 questions: what now, what next, and what if. So what's happening in the current state of the system, what's the next state forecasting, and what happens if we kind of change some variables and look at scenario analysis. So as Makhan mentioned, a lot of that time is also mentoring with the Deep Learning Academy and helping SSAI grow in machine learning aspects.
Wow, that's absolutely fantastic, Brandon. I appreciate you highlighting about your background and your experiences as well. Alex, I'm going to turn it over to you next. Would you mind telling the audience about yourself and describing some of the projects you have worked on at SSAI?
Thank you, Jason. So I'm Alex Belli, an earth scientist, a space geodesist, and also an AI/ML expert here at SSAI and also at NASA Goddard Space Flight Center. So my works blends cutting-edge space science technology with artificial intelligence, and the idea is to unlock new insight about how we understand the Earth as a system. And one of my core projects is called satellite laser ranging, which consists into firing small laser pulses to satellite to measure the distance with the Earth with an incredible precision. So think about being able to localize a satellite at a millimeter level. That helps us to track the Earth orientation, rotation, and position in space. And on top of that, it can give us a lot of information about what is happening on the Earth crust. If we have loading due to water going in the ground, or ice, all of these kind of questions that are extremely important for understanding the Earth changing. And I'm also specialized in studying space clock, which are critical for positioning. So everything related to GPS, navigation, and timing. So think a bit like GPS on steroids. And as an AI and ML advocate and expert here at SSAI, I'm really passionate about the potential it has to transform the science. And I always work with my colleague trying to tell them that it's really important now, it's the time to use AI, and we will discuss probably more about that later. And one of my projects I led on AI were time series of satellites, of data coming from satellites. The satellite were the GRACE and GRACE-1 satellite, which were measuring the gravity field of the Earth. And the data we were seeing on the satellite were noisy. As you can imagine, like real Earth data are quite messy. And so I was using AI and neural network in order to detect outliers. So let's think about pattern that we can miss in the data and things that are wrong, that we know that it's noise. So using AI helps us to be more powerful, to deal with the data faster because we had a lot amount of data, and also to open the door for new discovery. So I'm really thrilled about what AI can do and to be in this adventure with SSAI.
Wow, that's absolutely awesome, Alex. I appreciate you as well sharing your background and your experiences. See our planet through advanced satellites and sensors, where AI turns vast data into actionable insights. Here, Makhan Virdi explain how SSAI's innovations are transforming data use to protect health, improve emergency response, and strengthen security.
Like Alex said, this is the space where AI really shines. When you talk about collecting, visualizing data, and how do you distribute, how do you find patterns in that large volume of data, like finding the needle in the haystack. And you yourself mentioned know where AI can be used and also be careful about the possible downsides of AI, right? So, but this is one area where AI really shines, I would say. In my work across like different satellite missions, airborne campaigns, and data infrastructure, I have firsthand seen how AI is transforming Earth science. There are a lot of places where you should be careful about when to apply and when not to apply AI, but this is one field where we have to use it just because of the sheer size of the data that's coming in, especially with the new missions like Tempo and yet to be launched NISAR, NASA ISRO synthetic aperture radar. So going back to your question about DAC, so DAAC stands for Distributed Active Archive Center. So we have 12 of these data centers of different themes. Some of those data centers are working on the land data. The one that I work for is called Atmospheric Science Data Center. Then we have the Alaska Satellite Facility. We have the Snow and Ice DAC, and there are multiple DACs. So just to give the audience a brief overview of what a DAC is. So these are like all the data centers distributed across the country, acquiring and distributing data. So coming back to the question, right? So take our airborne field campaigns, for example. So these missions collect high resolution data, as aircraft spirals up and down through the atmosphere to capture the vertical profile of the gases and aerosols to figure out what's the composition of the atmosphere, what are the different gases contained within that column, especially flying over like high pollution or industrial areas. So historically, identifying those spiral segments from the flight track was time consuming, a manual process. But now we can use the time series classification algorithm to detect these spirals automatically based on the aircraft position and the other aircraft data like X, Y, and Z data, which is the altitude, the latitude, and longitude. So if those X, Y, and Z coordinates are clustered in a specific way, you can tell that the aircraft is going up or down, and then you can separate that set of observation from the other observations, right? So it's fast, accurate, and frees up scientists to focus on other actual analysis and not doing data wrangling. Historically, during my PhD also, like I spent 80% of my time actually gathering and curating the data than actually doing the science. So 20% of the time was actually spent doing a science, and that's still the case. We still spend a lot of time doing data wrangling. And the same is true for satellite data as well, Jason. In NASA's TEMPO mission, which is the first geostationary satellite that I mentioned, dedicated for monitoring air pollution over North America, it delivers hourly updates across the continent, going from the east to the west. It means we are moving from snapshots to a live feed of sorts of our atmosphere, right? And with that volume of data, AI becomes super essential. We can use deep neural networks and geospatial clustering to process TEMPO's imagery. We can detect anomalies, identify pollution patterns like recurring nitrogen dioxide spikes in urban corridors during rush hour or even after forest fire or volcanic eruptions in Hawaii or something. And we are exploring other models, AI models, to forecast AI quality trends using the sequence of observations from this high-resolution satellite data, right? So all of this allows us to respond faster, more intelligently to all these environmental changes. And AI's impact is not just technical, it's practical also. Like, for example, in emergency scenarios, we have that volume of data coming down from satellites and other ground stations. It's humanly not possible to process those data in time manually using the traditional techniques, right? But AI models can identify or help identify smoke, wildfire smoke plumes, can do flood zones dynamically, and also post-hurricane the roof damage using satellite imagery. So one example that stood out to me was using AI to detect the blue-colored tarps on rooftops after hurricane. So I went to school in Florida, so I spent 8 years in Florida. I lived through multiple hurricanes, so that's sort of important to me. So AI to detect these blue tarps on rooftops after a hurricane. So a fast way to estimate how many homes were damaged. You can just take the satellite imagery and then identify those kind of blue patches. And this is the kind of information that can shape where emergency crews go first and how aid is distributed, right? So these aren't just abstract outputs that we are talking about. These are tools that save time, resources, and potentially lives as well. And at infrastructure level, I think AI is helping us deliver that information in smarter ways. For example, I worked on developing a robust metadata system and also user-friendly data access tool called SOOT, S-O-O-T, suborbital order tool for NASA's airborne campaigns. These systems help researchers easily filter and download exactly the data that they need, because airborne campaigns are spread across the country or the world, and they are limited in terms of space and time. These missions last for a couple of months and then they stop and then they again collect the data. So it's difficult for scientists to go and find the data. So that system helps with this kind of analysis and discovery of the data. So at SSAI, we also built Chat SSAI, and Brendan was involved in that project as well. It was funded by the internal R&D at SSAI. It's our internal AI assistant that helps us navigate documentation and technical knowledge from our subject matter experts. For example, there were 500 plus peer-reviewed research articles that we fed into the system that people can query. So it's been fun to see that kind of conversational interface make its way into Earth science workflows too. And we are sort of bringing the sexy to Earth science domain, which is like mostly data wrangling and it's boring and all. So bottom line is, like, by infusing AI into NASA's data stream, we are able to go from raw observations from like all these large volumes of data into actionable intelligence faster than ever. So at SSAI, we can say like we are turning the fire hose of data into manageable sips. So people can get the right information at the right time, and that can literally save or prevent crisis or save lives. Looking ahead, I am excited about how we are applying these techniques. And with missions like Tempo and Maya, we are working towards linking air quality with hospital records and health trends. And AI will, I guess, play a critical role in uncovering those links and helping cities craft smarter, more responsive environmental policies, not only at city level, but state and central level as well. And what's more meaningful is watching young scientists take it further. For example, through our SSAI Deep Learning Academy, Alex was part of that in the cohort 4. And we have had the privilege of mentoring early career scientists as they build AI models on real NASA data, right? And they are not just learning theory, they are solving actual problems. And that gives a lot of hope for what's coming next by blending subject matter expertise with AI. And I think that's the key. Subject matter expertise has to be on the front seat, and AI has to be used as a tool to drive that.
At SSAI, AI drives real-world impact. Our guest, Brandon Smith, explains how the coupled reusable Earth System Tensor, also known as the CREST framework, and Earth System digital twins use machine learning, remote sensing, and simulations to predict and prevent crises like water contamination, natural disasters, and security threats.
So as Makhan discussed, data is really a very big part of machine learning systems. So just in the same way with digital twins, we first have to bring in a lot of data from a lot of different Earth systems. So we're talking about bringing in atmospheric data, oceanic data, terrestrial data, and trying to build a machine learning model that can learn from all of these different systems and combine them in such a way that it learns the relationships between the systems. So we have a scientific understanding that the Earth system has a bunch of different systems that are intermingled and have kind of these interconnections that aren't necessarily modeled if you're only looking at a singular system. So to produce a much more accurate forecast, a much more accurate model of the Earth, what we want to do is to actually combine all of these systems into a cohesive whole to be able to model those interconnections. So one of the main things that we're looking to do is to really generate more accurate products of the things that we currently have. So for example, I mentioned that I started out with water quality monitoring. So being able to forecast the likelihood of harmful algal blooms off of the coast that's harmful for human populations near the coastlines, and being able to forecast them more accurately would be a huge boon to health of human populations in those areas. So another example we're looking at is applying our system to understand how deforestation in the Amazon rainforests affect the crop yields and hydropower and kind of these downstream human impacts that deforestation would presumably have an effect on. So being able to say, how do these kind of large Earth system processes funnel down into the human level aspects that actually affect people on the ground? That is ultimately our goal with digital twins, being able to accurately model those processes and then being able to couple them with human impact models, like, as I mentioned, crop yields, being able to kind of forecast food security, power security, being able to address those questions that are most relevant to policymakers, to most relevant to people's lives in their day-to-day. So my goal with digital twins in this, so you mentioned CREST, the goal of CREST itself is really to build that machine learning powered framework that enables the construction of those digital twins, building out the data pipelines that enable kind of funneling in all of these different data sources into a singular location, being able to match up those different data. So you talk about different satellite missions have different resolutions. They'll be associated with different coordinate grids. So it's hard to natively kind of say, okay, well, this pixel refers to this location, that pixel is this location, match up the same spatiotemporal locations between different data sets. So a big part of CREST is building out the data pipeline that actually enables that, not having to worry about that in the actual machine learning algorithmic design. So as Makhan mentioned, a lot of machine learning projects, 80% of the time is data wrangling and only 20% is actually modeling. So we're really aiming to cut out that 80%, handle that in a much more automated fashion, and allow the experts to actually build the models themselves without having to worry so much about the data wrangling process.
Now, let's hear from our AI/ML subject matter expert, Alex Belli, who shares a visionary perspective on how artificial intelligence is revolutionizing space missions and reshaping the future job market, while highlighting how SSAI is pioneering cutting-edge AI solutions and empowering the next generation of innovators to thrive in this rapidly evolving landscape.
AI is a game changer, like it was probably for the computer or when internet first came out. I think it will deeply transform our work. And I want to take a small step back just to remind two important things. The first one is, for people that might be afraid about AI, let's remember that AI is just a tool. So like any tool, it can be learned, it has its limitation, and it cannot necessarily be optimized for a task you want to do. You will not use necessarily a car if you need to walk 2 meters. That's exactly the same thing with AI. And another thing is AI is a vast subject. Don't think about AI just as being like ChatGPT or this kind of language model. It can be simply a little program on your computer that will help you to solve or to read some data set you have. And like it was mentioned by Brandon and Makhan, one of the most important thing that we have, like the resources as a scientist have, is data. Tons and tons of huge amount of data. So much that without AI, it's going to be almost impossible for human to analyze them all. So we need a system. We need AI to be faster and to be able to analyze huge amount of data. And more than that, when we will send satellite or for the observatories on the ground, we will need an AI system that will be able to take decision, to know where to look and to act as a filter before to give the data to the scientist, to know where to look and what data are interesting to see. Because it's impossible right now to be able to open all of the data file and to read it. It will be too heavy, too costly for scientists to do that. So that's going to be a game changer on this aspect. And I wanted also to ask you a question. What do you think is one of the most amazing thing that AI can offer for scientists and for everyone? It's time. AI can give us more time. And as a scientist, usually time is something that we request to have more because we are thinker, we are problem solver, and we need that time to think about what's going to be the solution. And AI can do that. And I saw that in my work, for example, when I was trying to do a plot, so presenting a visualization of my result, I can use a chat assistant that will help me to have exactly what I want and to be to the point when I will do a presentation. And now with AI, I can do that in 1 hour, while I would have taken 1, if not 2 days in the past during my PhD, like 10 years ago. So now I have more time to do more and also to think better about what I'm doing. So now coming to the job market, your question about the job market. So I think that first, it's impossible to know exactly what's going to be the job market in the next 5 years due to AI. But if there is one thing I'm sure and that is happening right now, is AI is about competitiveness. People that will use AI will be more competitive than people that don't use AI. Not only for scientists, I can give you another example. Think about a plumber. Yes, a plumber doesn't need AI to repair pipes, but if the plumber is using AI to optimize their day, their schedule, that can be a game changer. So let's say that he has or she has like 10 appointments during the day and 3 emergency. Knowing the traffic in the region, knowing the weather, knowing what needs to be done, it can ask beforehand, where should I go first to be better, to be on time to all my appointments and even have more appointments. And that will be the competition that people using AI will have against people that don't use AI. So that will change the world, like computer change the world. It's almost, I think, impossible to believe a world like it was maybe 20, 30 years ago where computers were not part of the workplace. But now we don't even ask on a job post. There is not even asking, do you know to use a computer? That's obvious. So maybe in 5 or 10 years, knowing how to use AI, several sorts of AI, chat assistant or like more coding, depending on your work, that's going to be implied. Like the people will think that AI can be used by the person or not. And how do SSAI is rising to the challenge? I think SSAI, for 3 main reasons, is really well placed and is really like already like a center of excellence for AI. So first, we have an amazing pool of talent, a lot of scientists that know the data. They know how to deal with a huge amount of data, real data, not clean data, like what Brandon was saying. So meaning like data that are like messy, noisy, complicated, with hole in the series, data that are complicated, but they know how to handle them. And they know, and they are already using AI to solve amazing problems that were not able to be solved before. For example, to detect exoplanets using AI, or even to detect things on the ground, but what we did in the Deep Learning Academy, like to know what the satellite image is about, to recognize pattern, if it's grass, if it's wetland, if it's like cities and stuff like that. So that's already one aspect. The second aspect, and Brandon and Makhan here are part of it, it's education. SSAI is offering the Deep Learning Academy, which is amazing. I did it last year, like I was from the court for an amazing way to learn deep learning, to learn AI on real data and on what we do as a scientist. Also to collaborate with our people, to know our colleagues, what they do using AI. And SSAI is developing this education offer to be really like to have this power of offering classes to scientists and to anyone that will be interested to learn AI. So it can be like from simple, like what is AI, to Deep Learning Academy. And finally, I will thank the leadership, because I think they are really like forward thinker and really visionary, and they understood since already a long time that AI is the future, and now is the transition we have to take, and that AI is going to be everywhere, and they are going more and more toward AI-related problem, and they have this ability to know what to do and how to answer to this request for customers. So as a conclusion, I think, and I know that SSAI is already like a center for excellence for AI. We have great talent, great education, and a great vision from a leadership that is propulsing us forward, and we can answer to these challenges.